It's a really nice thing about having an intro, so you clap at the beginning. So I feel good already. We're going to be talking about Zend Framework 3 for the next 50 minutes or so. Who here used Zend Framework 1? Anyone? Oh, quite a few. Zend Framework 2? Okay, cool. Excellent. Zend Framework's been around quite a long while now. There was something called the PHP collaboration project that was announced by Zend in October 2005, which was the first time that Zend Framework was mentioned. And then the first code release was in March 2006. So we're very close to 10 years old now as a project. Version 1 came around in 2007. Version 2 came around about 5 years later, 2012. We're now 2016. We're another 4 or 5 years later. Time for Zend Framework 3. So what did Zend Framework 2 give us? What was the reason we did Zend Framework 2 in the first place? And there were 3 significant things that I think ZF2 had over ZF1. The first one being dependency injection. We finally found a way to decouple our objects without having to use statics everywhere. So that was quite nice. Then we had an event-driven architecture. The Zend Framework 1 dispatch system was very, very nice, but it was very brittle, very inflexible. And we solved that with Zend Framework 2. It was a very, very nice MVC system. It is really flexible. It is very, very good. And lastly, we introduced standalone first-class modules. We didn't have them in Zend Framework 1 until about version 1.6, 1.7, something like that. And they were very much bolted on. Nobody wrote individual separate modules in Zend Framework 1 that could be shared. And we solved that with Zend Framework 2. So Zend Framework 2 has been a very nice framework. It was a very big improvement over Zend Framework 1. We like it very much. We're quite proud of it. What's wrong with Zend Framework 2? Not that much, to be honest. As I say, it's quite a good framework. We like it a lot. Biggest problem ever was the backwards compatibility break from Zend Framework 1. We saw the new shiny. And we're developers, like everyone else. So when we were allowed to break backwards compatibility, we broke it. We broke it hard. Who tried to upgrade an app from Zend Framework 1 to Zend Framework 2? Next to no one. That experience was horrible. It was really, really difficult. And as a result, everyone stuck with Zend Framework 1 for their old projects and did their new projects in Zend Framework 2. Which is one of the reasons why we still support Zend Framework 1 today. It still runs on PHP 7, because Zend Framework 1 has got a lot of apps out there that are built on it. It's important that they can still run. We don't want to do that again. Another problem with Zend Framework 2, we put in all these cool new features like dependency injection, like event management, etc., which resulted in a steeper learning curve. ZF2 is harder to learn than Zend Framework 1. We targeted the expert developers over maybe the novices. So that was interesting. And we also coupled things more than we thought we had done. We thought that we were creating a separate component library, lots of separate components, but all integration is via the MVC system. So that was a side effect of the way we built our MVC. We ended up doing all the integration via the MVC component. We also had a number of development challenges, but realistically, you couldn't care less about those. The PHP world has changed a bit since 2012, when ZF2 was released. So we started doing Zend Framework 2 in late 2010. Betas were in early 2011. Composer wasn't a thing at all. We thought that pair would be our main distribution mechanism. Hand up who uses pair here. Voluntarily? Yes. All the hands went down. Nobody uses pair anymore. The only reason we use pair is so that we have PECL so we can install Xdebug. I assume there's some other uses for it, but nobody uses it at all. Everyone uses Composer. Is everyone not choosing Composer? Actually, don't do that, because you'll put your hands up and embarrass yourselves. If you are not using Composer, get with the program. The PHP community has decided that Composer is the way we do package management. Live with it. Don't try to go outside the system. It's worth learning. It is good. It works very well. So we've got Composer now. PHP 5.3 was the target for Zend Framework 2, and we had arguments on the mailing list about whether that was too modern. Think about it. Too modern. So we've now got PHP 7. So lots have changed in terms of the type of PHP we can write nowadays. And we've got a load more useful standards in the PHP community. We're sort of used to the idea of working with other products, other libraries, through things like the standards that the Framework Interoperability Group have created. So the PHP world is a little bit different. Which brings me to ZF3. What's the story for Zend Framework 3? 4 things that we're interested in. Firstly, componentization. We want to encourage more use of our components outside of the ZF MVC system. We'd like to improve the performance and usability. Everyone likes things to be faster, so we think we can make things faster. That's good. And we would like it to be more usable. We'd like it to be a slightly shallower learning curve. We'd like to improve the MVC a little bit. We like our MVC, we can make it a bit better, we're going to do that. And we're going to do something a bit about our documentation. It's a little bit not as good as it could be in Zend Framework 2. And lastly, we've got a bit of a focus with PSR 7, which is one of the Framework Interoperability Group standards. Interoperability and middleware, we think, are going to be really key in the next 4 or 5 years. So we think that's important. We think that's going to be key to the way we develop applications as a PHP community. We would like to be helping on that front too. So let's start with PHP 5.5. That's the version that we've picked for the new minimum version for Zend Framework 3. You've got to be running 5.5 or above. Again, don't raise your hands if you're not running 5.5 yet. Just be embarrassed. It's ridiculous in this day and age. We've picked 5.5 because that's what the long-term releases are on at the moment. I'm hoping that all the big distros go to version 7 for the next LTSs. That would be nice. So 5.5 is where we're starting. And yes, 7 is out. 7's got lots of new stuff in it. 5.6 is good. But 5.5 has also given us a lot of new things that we couldn't use in Zend Framework 2 that we can now use. We got traits. The callable type hint. That's finally usable to us. That helps in our event manager. We've got the finally keyword in try catch. That's useful. Password hash. Half a Zend crypt can disappear. That's quite nice. Colon class. That is useful in say, the service manager. Short array syntax. Everyone knows that Zend Framework configuration is very array-based. It looks a bit better with a short array syntax. We get generators. There's a lot of new stuff in 5.5 that we didn't have in 5.3 that we're quite excited about. Makes the development more interesting. So let's talk about the components first. Key thing we have done, and this is a bit of a development thing, is that we've got separate repositories. In Zend Framework 2 up to 2.4, everything lived in one massive repository, Zend Framework/Zend Framework. And from 2.5 onwards, we have split it into separate repositories. So each component now lives in its own repo, which has got lots of benefits. We've also converted it to PSR 4. Has everyone heard of PSR 4? Some people, maybe. It's an auto-loaded standard where we get rid of the empty directories that were there for no apparent reason. It's quite nice. Makes life a little bit easier for autoloading. It's a little bit more predictable. It's fast. Composer's autoloader is very nice, so we're using that. So we're on PSR 4 now. We can separate the evolution of our components. There's nothing to stop us changing a version number on one component compared to another component, which we cannot do with Zend Framework 2. So to pick a good example, Zend log. We had a patch for PSR 3 in Zend log a little while ago, and we could not release it because we didn't want to bump the version number of the main MVC system. We weren't ready to do that. So we had to hold back on a feature in Zend log because we weren't ready to upgrade the version numbering and what we were doing on Zend MVC. That problem goes away. We've also got some It's fairly stable components. Zend barcode, for instance. How frequently do you think Zend barcode changes? Not very frequently at all. It's a very nice stable component. It just does what it does without any problems. Every time we change something in Zend Event Manager, the version number of Zend barcode goes up. You might think there's a new feature in there. There isn't. We haven't changed it. It's stable. We can now control the evolution of each individual component individually. We've put the documentation back in the repository. In Zend Framework 2, the documentation is in a separate repository to the source code. In Zend Framework 3, in all the components, we're back into the same repository, which means that when we get a pull request for a new feature, we can insist on documentation for that new feature at the same time. So I'm hopeful that our documentation will get better. That'd be nice. The issues are in the right place. If you've got a problem with Zend Service Manager, you raise an issue in the Service Manager component. You'll be able to find all the issues related to a given component. They're in the right place. So that's quite helpful as well. And finally, we're encouraging more maintainers. We're looking for more people to help with Zend Framework. By having separate components in separate repositories, we can give people commit rights to their area of specialism. So if you're really, really good at Zendorf, as someone was talking to me yesterday, I would like you to be a maintainer for Zendorf. I don't necessarily want you to commit to Zend Event Manager because maybe you don't know anything about Zend Event Manager. You should not feel responsible for Zend Event Manager. So we're looking for more maintainers around each individual component. So that's what we do with components. They're all separate. They are now got their own evolutionary paths. Which brings me to the MVC system. The Zend Framework 2 repository from version 2.5 has got no code in it anymore. It's all gone. It consists of a Composer JSON file that points to all those separate repositories. So although I've been talking about Zend Framework 3 in terms of the components, it's actually from version 2.5 that these things have been happening. We have got a ramped evolution path between version 2 and version 3. So 2.5 was where we split all the components out, and the MVC package is literally just a large Composer file with every single component listed out in it. This means, and I talked about this before, that the components can upgrade and they can evolve separately. So we will see new major versions of our components that the MVC system will pick up when it is ready. So we might get a version 3 of Zend Event Manager. We might get a version 4 of Zend Event Manager. The MVC system might stick to version 3 for a little bit before it accepts the next major release. We have that flexibility now. The other thing we can do, we're going to reduce the number of dependencies. Going back to Zend barcode. You install Zend Framework 2 today, you get Zend barcode. Yay. How many of you have used Zend barcode? Yeah, precisely no one. Oh, one there. Oh, sorry, I missed you. One person has used Zend barcode. Every single Zend Framework 2 application out there has the source code in their system. Why? That doesn't seem very good use of resources. It takes a little bit longer to do your Composer install. So we can reduce the number of dependencies for the ZF3 MVC right down to the components required for MVC. And we're going to be quite harsh about this. So ZendDB will go because people use Doctrine. Not everyone needs a form, so Zend form will go. You will have to install these things independently from the main framework. And of course, this comes back to the fact that Composer is a thing. If you go back to 2012, how would you do all this installation? Would you really use pair? It's not very easy to add different components to an application. So we felt it was better just to bundle everything. With Zend Framework 3, with Composer, if you want to install Zend Form into your Zend Framework 3 project, Composer requires Zend Framework Zend Form and you're done. It's very, very easy. The integration is now with the component. so that the Composer install will have a post-installation script that will set up your application config for you, which will enable you to register the correct service manager and event manager requirements for that particular component. So that's quite cool. I quite like that. There are going to be BC breaks. We're not going to do a major version number and not break BC, because there are reasons to break BC. We are going to manage it, though. We are only breaking BC if there's a clear performance win or there's a clear usability win. We are not going to change BC because we think it would be cool. Everyone in the Zend Framework 2 application will be able to upgrade to Zend Framework 3 with a minimal amount of effort. I'm expecting everyone to upgrade. This is not a Zend Framework 1 to Zend Framework 2 transition. 2 to 3 is doable for everyone. That is a key requirement of every single patch we are reviewing. We've already started getting the components up to 3.0. There's about 5 or 6 components that have now got a 3.0 release. The 2 big ones for the MVC system are Service Manager and Event Manager. Both of those are now version 3. And obviously, these are the key foundation of what Zend Framework is and what the MVC system is. So we're going to look at those. Also, because I really like them. I really, really like Zend Service Manager. I think it's a great DI container. So the first thing we did with Zend Framework 3, well, actually, Zend Framework 2.6, is container interop compatibility. Has everyone heard of container interop before? A few people. It's an independent standard for defining what a container should be, to retrieve a dependency out of a dependency injection container. And it's got precisely 2 methods, has and get. It is the world's most simplest interface. It works really, really well. And the number of projects are now supporting this interface. So Zend Service Manager 3 also supports it, which makes it really easy for you to take Zend Service Manager, for instance, and use it within Slim Framework. Because Slim Framework requires a container interop DI container. These sort of interoperability things become far easier if we do things against interfaces. We've improved interfaces within Zend Service Manager. Things like factory, abstract factory, delegator factory, they've all got slightly different function signatures within interfaces. We've improved that. They're now all __ invoke. That's one of the benefits of going to 5.5. We can do that. So everything that looks like a factory in Service Manager 3 uses __ invoke. Back to the whole managed BC break thing, you can do that today in your Zend Framework 2 applications because it works there as well. We've also made the first argument to the factory the container. It's now predictable. If you're writing a factory for Zend Service Manager 3, the first argument is always a container. That is not true in Zend Framework 2. Hence, you have to keep looking up in the docs. And you all know my opinion of the docs of ZF2. Let's try not to go there. Make it more predictable, easier to use. We've also allowed you the ability to reuse a factory for multiple named services. So if you've written a factory, you can now assign it to more than one place within your Service Manager config, which reduces the number of abstract factories you need to write. So it's quicker and easier to write them. Again, that works in the later versions of Zend Service Manager 2, because we've backported the feature to make it easier for you to transition from one framework to the next. New method, build. Everyone's used to using get. Get will get you a shared copy of the service out of Service Manager. What happens if you want a non-shared version out of the Service Manager? Now you use build. Build will give you a new instance of that service out of the Service Manager. That's really, really helpful for the plugin managers, like the form input fields, the validators. You do not want the validators being shared. We now have a method to make it easier to pull out the non-shared versions. So again, improving the API to the component. Zend Service Manager 3 is immutable. Once you have started pulling things out of the Service Manager, you cannot configure it anymore. The reason we did that is it is 20 times faster. It's really, really quick. Zend Service Manager, in the worst case, is 4 times quicker than the current one. So version 3 is really, really quick. It's 20 times faster in a lot of cases. Very, very nice to use. We like it a lot. You just put in Zend Service Manager 3 and everything goes quicker. It's very, very nice. And that's mostly down to the immutability. There's a few other bits and bobs, but making it immutable removed an awful lot of runtime check code. So get became much, much faster. And, as I say, mostly backwards compatible. Not that many changes that you need to make to your source code to run with Service Manager 3. So these are the key changes, which is a polite way of saying the backwards compatibility breaks. The really, really big one is that top one on that list. Service name is now case sensitive. You can no longer put configuration into the Service Manager in one format, like all uppercase, and then use it all lowercase. You have to remember how you put it in to retrieve it out again. This is one of the reasons why we always use class names, because we know how they're spelt. Really, really minor one, the constructor now takes an array rather than a specialized config object. You probably don't care about that very much if you're using Zend Framework 2's MVC system, because the MVC system worries about that, not you. But if you're using Zend Service Manager outside of ZF2, it is now much easier to use. It behaves the way you'd expect it to. As I say, the new interfaces for factories are always __ invoke, so that's quite an easy change. You're probably already doing that for most of your factories anyway. Another key one, if you write in a plugin manager factory, so you're writing a view helper, for instance, a factory for a view helper, the parameter to that factory is now the parent service manager. So you no longer have to go and get the parent service manager yourself. It's made life a little bit easier for you. So that's Zend Service Manager, a very narrow set of BC breaks for an up to 20 times performance increase. We're quite happy with this. We think this is a really, really good trade-off. And the other thing that we've done, both with Service Manager and with Event Manager, is we have got a really good migration guide. It's in the documentation. The documentation is in the component. So when people kept adding these BC breaks, we made them write down what they'd done. Amazing. So we now have a good migration guide. You can read the migration guide for Zend Service Manager, and it makes sense. It's very clear what you need to do. In all the cases where you need to make a change, we have documented what you need to change. It shouldn't take you long to upgrade. Event Manager. We've done the same thing. We have made it much, much faster. It is 4 to 15 times faster than the one in Zend Framework 2. Mostly because we re-implemented priority queue. So in Zend Framework 2, we use SPL priority queue. In version 3, we've implemented it ourselves in a slightly different way that is optimized for Event Manager, and it made it much faster. We've made some usability improvements to the trigger method. Trigger is a particularly complex method within Zend Event Manager 2. It is much saner in Event Manager 3. And yeah, BC breaks again. Mostly backwards compatible, not completely. But each BC break has been there for a reason. And the two big ones are we wanted the speed and we wanted the usability. So again, which are the BC breaks? If you're using Global Event Manager or Static Event Manager, they're gone. You probably weren't using them anyway. Globals are bad. I think we've mentioned this before. If we don't use globals, we've got rid of them. They're gone. List and aggregates have been removed. You might be using those It's a 2-line change to your source code to use it in the new way. And again, it's in the migration guide. Very, very easy to change your code to handle that fat. That gave us a 2 times speed up in using Event Manager. So you have to make a 2-line code change. We got a double performance. The construct signature has changed for Event Manager. You now have to pass the shared Event Manager in as a second parameter if you want a shared Event Manager within your Event Manager. So it makes it far more explicit what is going on in terms of the way shared Event Manager works. So you might need to look at that. And as I say, we messed around with trigger. In Zend Event Manager 2, there are 36 different combinations of calling the same method. Hands up if you can name them. 36! Unbelievable, isn't it? There are 4 parameters that go into trigger. There's the event name in version 2, there's the event name, there's the target, there's the argv, and there's a callback. And the event name can be a string, or it can be an event object. Alternatively, you could make the event name a string, and the target could be an event object, or it can be an instance of a class. Similarly with argv, do you fill it in or do you not fill it in? 36 different combinations. We thought this was probably not the most usable method in the world. In Event Manager 3, we have changed trigger to become 4 different methods. We have trigger, trigger until, trigger event, and trigger event until. So if you want to use an event object and create your event object and then trigger it, you have to use either trigger event or trigger event until. If you want to use an event name as a string, then you use trigger or trigger until. And then the difference between the two in each case is that the callable for the short-circuiting is in the until version. So if you're not short-circuiting, you use trigger. If you are short-circuiting, you use trigger until. Makes it quite clear what's going on. So you've got to now learn 4 methods instead of 1, but they make sense. So we think that's a very, very good trade-off. All those changes are forwards compatible from Zend Framework 2.7. So if you upgrade your ZF2 application to 2.7, you can use all of those 4 methods with those signatures today, so that when you move to Zend Framework 3, all that work has already been done. It's a very, very shallow migration path here. We're trying to make it really easy for you to go to Zend Framework 3. Zend MVC version 3 is fundamentally the current MVC, but much faster. There's next to nothing you need to do for Zend MVC. Significantly, you're going to change the factories related to the Service Manager stuff, you're going to change triggering related to Event Manager, and it will all just work. There's going to be a new middleware listener in there, there is a PSR7 bridge, there's a few other bits and bobs, but to all intents and purposes, Zend MVC 3 will be very, very similar to Zend Framework 2. This is why we think you can all upgrade. So that's where we are at the moment. We've got our MVC system. It is very powerful, it's very flexible, it's event-driven, it's got DI, we like it a lot. Where's the PHP community going? What's been happening in terms of the PHP community? And where do we think the future of PHP application development is going to go? Those are the questions we've been asking ourselves in terms of what we want to do as part of the 3.0 story. And we come up with these 3 things. We think there's going to be much more dependence on abstraction as we go forward in PHP development. We think more people are going to be building against interfaces than building against concrete implementations. So things like PSR3 for logging. You're going to write your component, you're going to accept a PSR3 logger. You will not care which particular implementation of that logger. You'll just go right to the interface. We think the same thing will happen with things like PSR7 and request and response, container interop for handling dependency injection, etc. So we're seeing a lot more writing to interfaces, dependence on abstractions. Everyone is using packages now in Composer. We are expected to build our applications up using components on Packagist. We are going to be building our applications out of smaller bits. We're not so scared about how we're going to find these components. We know how to find a library nowadays in PHP. We know how to install it and get it running in our application with no work. Now, back in the old days, you would grab something off PHP classes and spend 3 days getting it to auto-load. Now we just type composer require, and suddenly we've got a working component. It's just been brought in. You don't need to depend upon a whole family of components that came from one framework, because you can just grab them out of Packagist, the ones that you actually need, the bits you need. So we think the framework should be right out of the way. It shouldn't be the thing you are thinking about anymore when it comes to building your application. You'll be thinking in terms of components. And the big thing there from our point of view is PSR 7 and interoperability and things like middleware. Was anyone in the PSR 7 talk yesterday? Okay, well, I'm going to repeat what that guy said. So you already know this stuff. For the rest of you, has anyone heard of PSR 7 in general? Okay, a good few of you. For those of you that don't, let's go through a whistle-stop recap or information about it. We are web application developers. That's what we do. We build things for the web. PHP is really, really good at building things for the web. It is less good in a real-time operating system. It's very good at HTTP and the web. When it comes to HTTP, it's a really, really simple protocol. There is a request, and there is a response. The browser sends us a request. We send the browser a response. Very, very simple. And it's all text. There are 3 sections to the request. There is a request line with the method, whether it's a get or a post or a patch or whatever. Which URI are we actually going to route to is part of the request line. We have some headers, key value pairs. Then we have the message body. It's all strings. It is all very, very simple and very easy to understand. The response looks exactly the same. We move the version number to the beginning of the response line, we put status code in, and the rest of the message stays the same. We have headers with key value pairs. We have a message body, which is just a string. Okay, that's all that HTTP is. There's an awful lot of RFCs about that very, very simple concept. How do we do that in PHP today? If we want to get at the request information, we have the superglobals. We have $_server, _get, _post, _cookies, _files. We have all of the superglobals. Then we have Apache request headers for the bits that don't go in the superglobals, which works in Nginx. Now. It didn't. It does now. And then we've got PHP input for the message body that doesn't go in post because we've got a different MIME type this time. You have to know what you're doing to get the right data out of PHP from that very, very simple HTTP request. There's quite a lot of choice involved. You've got to know quite a lot. And in terms of the response, we have header. Header is a very simplistic method. It takes 3 parameters, and it has got 2 exceptions that depend upon the data you put into it that nobody ever remembers. Nobody knows what they are. We have echo. We need a string for the message body. To send back our response, you just echo it, which works wonderfully, right up until the point where you need to send a header after you've started doing the output, at which point you can't do it, so we invented the output buffer to solve that problem. This system is one of the areas where you can tell that PHP is 20 years old. It's a very CGI view of the world. So PSR 7 is a model of the request and the response in HTTP as objects. Specifically, it is a definition of some interfaces. That is all. There's a request interface and its sister server request interface. There's a response interface, a URI interface, and an upload file interface, and a few other child-dependent ones. It's not particularly complicated. It's just some interfaces. This isn't a PSR7 talk, so I'm only going to tell you 2 things about PSR7. And if you take nothing away from this talk, remember these 2 things. They will stand you in good stead. No matter which framework you use, if it's got PSR7 involved, these are the key things you need to know. Firstly, request response, URI, and upload file are immutable. Immutable means you may not change it once it has been constructed. So in the first line there, I instantiate a new URI object to the events collection on joined in. I now have a URI object that I cannot change. That's not particularly useful. To change that URI object, there is a series of methods that all start with the word with. So you've got with query, you've got with fragment, you've got with domain, etc. When you call URI with query, and this time I put in the upcoming filter onto that collection, I get a new object. So URI2 is not the same as URI. The most common mistake you will make with PSR7 is you will forget to reassign the object that comes out of a with. Everyone does it. And you wonder why none of your code works. You forgot to reassign. The huge benefit of being immutable is it is very, very predictable. We know exactly what is going on with our code. Our code is very, very easy to test. It doesn't change under our feet. It's quite nice. I can reuse the $URI variable and create multiple queries against the same object. So I get quite a lot of flexibility as well, and I can know what I'm doing. And similarly, the request does the same thing. Here I create a new request, with method, with URI, with the accept header, with the authorization header. I've just created 5 new objects. It's really, really fortunate that PHP is very, very efficient when it comes to object cloning. This is not particularly inefficient, and it is not particularly slow. You will never, ever see this on the profiler. It's quick. Okay, so that's key feature 1. Key feature 2, the message bodies are streams and not strings. So I know I said that the request body and the response body are strings. In PHP, in PSR7, we model them as streams instead. The reason we model them as streams is it is extremely memory efficient. So lots and lots of different components are implementing PSR7 now. So we could have an object from Guzzle, which is PSR7. So this will be a file, for instance, and we want to download it and send it to a browser. If it's a big file, we do not want to load all of that into our own PHP memory space. We just want to pass it straight through to the browser. That is what streams do. They allow us to be very memory efficient in our PHP process. They are also mutable. So the rest of PSR7 is immutable. Streams are not. You can change them. So be aware of that as well. Okay? So that's the only 2 things you need to know. Immutability and streams. Diactoros is Zend Framework's PSR7 implementation. So this is our component that implements the PSR7 interfaces. It is a complete implementation. It implements every single interface in the PSR7 standard. I'm only aware of 3 components that actually do every single interface, and Diactoros is by far the most popular. We have a few specialized responses. It turns out that we do quite a lot with JSON nowadays. It turns out that we send redirect headers quite frequently. It turns out that we send empty responses quite frequently as well. So there are some specialized responses built into Diactoros to make that easier for you. It is used by Symfony for their PSR7 bridge. It is used by Zend Framework 3 for Zend Framework's PSR7 bridge. Therefore, it is used by Laravel when they need to go to PSR7. It is also used by Drupal. They use Symfony components. They use HTTP Foundation. If you need to take from HTTP Foundation and get into PSR7, you're going to be using Diactoros. This means it is very well tested. remarkably bug-free, because an awful lot of people have been using it and sorting this out. It's very, very nice. The thing about having a standardized request and response object is that we can start manipulating requests and responses in a library-agnostic way, in a framework-agnostic way. We can take an HTTP request, modify it, and do something with it independent of anything else. And that's called middleware. Middleware is not new at all. It will become more and more important in the PHP world, but you can see it in every single other web language in the world. In the Node world, it's called Express and Connect. They are what they do in middleware and stuff like that. Python, WSGI. In Perl, it's called Plaque. In Ruby, it's called Rack. There's obviously some symbiosis going on there. In the PHP world, we've had something in the Symfony arena called Stack for a while. Zend Framework has had middleware for at least the last 3 or 4 years. It is quite a common paradigm, and I think we will see it much, much more over the next few years. It will become the common way to manipulate requests and responses in our PHP applications, primarily due to PSR 7. So when I talk about middleware, this is a basic concept. Everyone else uses a sort of onion target thing, but I get confused by that one, so I don't use it. We have discrete components, discrete things. So I've got a session, I've got an auth, and I've got my app. For each block of code, I get a request and a response, and I can do something with them. Optionally, I can then pass them down to the next component, the next block of code. So I've got my session. I might look at the cookie for the session cookie and load the data out of the database or whatever, start the session up. Then I can go to my auth component. My auth component might look at the authorization header in the request object. If there isn't an authorization header, maybe it will terminate and send a response back, a 401, for instance. Or it might say, yes, you're logged in. You may run the app. So we have the situation where the request and response goes into a block of code. That block of code can do something with it, move it onto the next block of code. It is a very, very simple chain or stack. You can see where the Symfony guys got their name from. Code-wise, it looks something like that. It's just a function signature. It's just a callable. You take a request, you take a response, and you take the next one in the chain. You return a response. The only requirement is you must return a response. So you can do something with the request and response beforehand. If the next is valid, i.e. not null, you can call it, or you can choose not to. It's up to you. And then you can return the response at the end, or you can do something with the response before you return it. It's a very, very simple paradigm. All of you understand exactly what that code does, and it's been on slide for maybe 10 seconds. Very, very easy to write, very, very simple pattern. Modify the request and response, invoke the next middleware, modify the returned response if you can be bothered, and then return it up the chain. Strategility is ZF's middleware implementation. I did not name this, and I apologize. What can you do? At least it has the benefit that you're more likely to spell it correctly for Google than you are Diactoros. They're both nicely unique words, but if you can't spell them, Google can't find them anyway, so I'm not sure how much we won there. Strategility is simply a mechanism for running middleware. You register your middleware strategility, you execute run, and it will run your middleware down the chain for you. That's all it does. It's not particularly complicated in terms of its concepts. Middleware format in strategility is any callable. We've already seen the signature, and there is an interface if you would like to have an object-oriented thing to type int against. So which is simply the same signature, but within the interface. So very, very simple. One thing that Strategility does that's different from the other middleware stacks out there, because there's 2 or 3 now that use PSR7, is that it does error middleware. And if you're used to the node way of looking at the world, then this should look quite familiar. If you pass a third parameter to next, then instead of going down the middleware chain that runs your application, you go down a different middleware chain, which is the error middleware chain. So we can process our errors in exactly the same way as we can process our standard application. So you can do quite a lot with your error handling in terms of how you want to present your errors back to the browser, using exactly the same paradigm as for writing your main application and the middleware for manipulating requests and responses in your main application. So that's quite cool. Again, it's got an interface. Strategility does path segregation. So we can split out blocks of middleware and only run them if there is a particular prefix on the URL. It's not a particularly complicated system. It's not a router. It is simply a path match. So we can only run the blog middleware if we're in the /blog path, for instance. We can nest middleware. So we can create a set of middleware in a pipe, and we can attach that against a given path. So we can create a tree of middleware. And what that allows us to do is to wrap other applications within middleware. So we can have a Zend Framework 2 application as part of middleware pipe. We can have Zend Framework 1 application. So we've got integration between different applications, all within the same set of standardized request and response manipulation. And this is actually being used in the real world. A friend of mine who's actually on the Slim Framework project wrapped a code igniter application into a Strategility middleware in order for him to build his new functionality independent of the legacy CodeIgniter application, but have a standardized session system. It worked really well for him. You're going to need some routing, though. A simple path matching isn't good enough. You are going to need a DI container. You are going to have to write the rest of your application somewhere. In Zend Framework 3, the MVC system allows routing to middleware. So we can route to controllers at the moment. You can now route to middleware. That's quite convenient. That new middleware listener enables you to do that. But much more interestingly is that we've written a microframework called Expressive. Now, this is a name I do like. I think Expressive is quite a good name. It's easy to Google. Zend Framework's microframework is very, very simple. It is always written against interfaces. So it's a routing interface, a container interface, an optional templated interface, and it provides your error handling for you. That's all it does. It's a micro-framework, literally. And it's agnostic. This is part of what I was saying about we want to be more interoperable. So you don't have to use Zend Router. You can use Aura's router, or you can use FastRoute. By default, we prefer FastRoute with Expressive. It's a very, very nice router. I think everyone is using FastRoute now. It's becoming very standard. I know Lumen uses it, Slim Framework uses it, Expressive uses it. I think they're the main 3. DI container, Zend Service Manager, Pimple, Aura DI, any container interop DIC, they will all work with Expressive. We're not boxing you into a corner by using this micro framework. Similarly with the templates, plates, twig, send view, it's up to you. Installation is via Composer. Composer is the way we do things in the PHP world now. So when you do a Composer create project for Expressive Skeleton, it will run a script that asks you which components you wish to install. Do you want which router, which container, etc. And then it will install them and create your Composer JSON for you. And it's really, really simple. That's an entire Expressive application on a slide. I can't do that with Zend MVC. I don't think I could explain the whole MVC system in the length of this talk. But I can explain Expressive on one complete slide. That's how much simpler a microframework is. You create your application from the factory. You write your route handler, in this case, a get method that responds to /hello/name. You write a callable that is middleware. Set up your application for piping the routing, piping the dispatching, and then you just call run, and you're done. It's not very complicated. You build your application up out of these very small, very simple middleware methods. Just like the MVC system, all your real application, or your service, or your domain layer is completely independent of the dispatching anyway. So you still have to write your own model. That's not Expressive's problem. It wasn't Zend MVC's problem. Again, you can add other middleware, like session middleware or auth middleware. The method we use is called pipe. So I called it a stack. As far as Expressive is concerned, it's considered a pipe of middleware. And you just run the request down the pipe. There's no templating by default in Expressive. Back when we wrote Zend Framework 1 and Zend Framework 2, we thought that everyone wrote HTML websites. Nowadays, a lot of us are writing APIs. You don't really need a view templating system for an API. You just need to be able to generate JSON or XML. So views are not provided by default. There's an interface for it. You can install a component for doing your views. It's part of Expressive in that sense. But not all Expressive applications will need a view, so it is not provided by default. We only provide the code we know you will need. All template agnostic. The higher thing is agnostic. So, why do we write Expressive? Number one reason is it's quick. We've just made Zend MVC version 3, 4 to 8 times faster than it was. Expressive is much, much faster. It does very, very little. You can't go wrong. The developer experience, as I say, I explained how Expressive works in a single slide. You can't do that with Zend MVC. It's a very, very easy system to understand. It's a very easy system to pick up. I think microframeworks and those type of dispatch systems will become the de facto standards because they are easier for everyone to work out what's going on. And the whole concept of reusable middleware. Not that particular signature, request, response, next, is used by a lot of frameworks now. You could use middleware that's written to that pattern in Slim, in Radar, in Expressive, in Lumen. Not sure about Stack. I've never actually written anything in that sort of over there, so I don't know. But there's a lot of commonality going on. So if someone has written some middleware for PSR 7, you can use it in Expressive. You don't need people to write Zend Framework specific plugins or Zend Framework specific modules. If someone has written a piece of middleware that they needed for their Slim application, you can use it in Expressive. There are sites that are, and GitHub repositories that are springing up that are full of PSR middleware. Very, very small components that you can chain together in the order that you need them to work in. It's very powerful. So this is what we're calling the Zend Framework 3 era, or the Zend Framework 3 story. It is much more than just a version upgrade on our MVC system. We're doing a lot more. We're creating separate components that you can use independently, far better than you can in ZF2. We are improving the MVC. We still think the MVC is important. It will have a version 3 tag. We like it a lot. We think it will still be in use. We expect everyone to upgrade to it. Strategility, the PSR 7 middleware foundation, and Expressive, our microframework, we think are where the future will be in 5-6 years' time. So that's where we're going. The whole point of all this is to help you write the applications that you actually want to write and not feel like you are constrained within the Zend Framework box. That's it. Has anyone got any questions?
When you talked about the service manager and you said that factories should use the invoke magic method now?
Yeah.
Do you know if it's backwards compatible to the factory interface?
Yes.
Okay, cool. Thank you.
It is indeed.
Thanks.
We're very, very big on backwards compatibility in Zend Framework world. There's a reason why Zend Framework 1 is still supported. We still bug fix Zend Framework 1. We fix any BC breaks we accidentally introduce in Zend Framework 1. We do the same in Zend Framework 2. There was no way we were going to do a change to ZF2 to make it migratable to ZF3 and make it backwards compatibility or incompatible. So yes, the interfaces have been swapped around. So in Zend Framework 2.6, I think it was, no, 2.7, we swapped the interfaces around from the factories so that the new interface is the parent of the old interface. So you can literally migrate every single factory you've got now to the new format and still run your Zend Framework 2 application. Anyone else got a question? Or was I so clear that it all made sense? There's one at the back there. I like watching people run. It's good exercise for them.
Hey. How would you compare using Expressive to using Slim, and do you have a favorite?
Do I have a favorite? Right, so I'm also a core contributor to the Slim framework, so I have skin in both games. They've got slightly different focuses. Slim framework is smaller in some ways. It is more tightly coupled. It is easier to get going with in some ways. And Expressive is more correct in terms of the way you handle dependency injection, the way that it builds up the agnostic routing, for instance. So you can't swap out the router in Slim as easily as you can in Expressive. I like them both. I've got apps in both now. Well, when I say I mean my clients, because I don't do very much in terms of actual writing code anymore. I just direct other people. Yeah, and it depends on what you're trying to do. The Expressive application that I'm currently involved in runs on an AS400, for instance. Zend have got the resources to check it works on an AS400. The Slim framework doesn't. So clearly, if you're targeting platforms like that, you're targeting an AS400 running the DB2 database, running Zend server, then Expressive makes a lot of sense. If you're writing a very small API that's running a little microservice or something or another, then you might get going with Slim a lot faster. There's less code to learn this. It's a much smaller framework. So even within the microframework world, we have very small frameworks and we have slightly larger microframework. So your mileage varies, as they say. Does that help? Okay, cool. Anyone else? Because if you're waving right at the back, there's no way anyone can see you. So you just have closer. Okay, I assume that there aren't any more questions, so thank you very much for listening. Please rate my talk on that URL there, or just go to Joined In. PHP UK conference will be the top of the hot events list by now, at least it ought to be. And rate every other talk you see as well. I help maintain Joined In. I would quite like to see lots and lots of ratings for this conference on my website. Thank you very much.